So let's talk about pressure measurement now. We're going to talk about two different ways to measure pressure. These are just simple devices. There might be other ways, but these are only two ways we're going to talk about. First one's going to be a manometer, and then we'll also talk about a barometer. Now both of these devices are going to measure pressure in terms of a column of liquid like mercury. And the reason why they use things like mercury is because mercury has a high density. Right? And the reason for the high density is so that the device can be a reasonable size. Right? Because if you had something with a low density, the device would have to be larger. All right, so let's go ahead and draw a picture for the manometer. So let's have something looks like that. All right, so this is a tank. And there's, pressure in here. There's some kind of gas in here, and there's a pressure P. Now attached to this is going to be a device, and it's going to be called a U-tube manometer. So it'll look like this. Okay, so this will be open right here. So the pressure from the tank gets felt in here in this tube. Now inside of this tube is going to be a liquid. All right, so this is going to be the manometer liquid. And this has a certain density, rho, whatever it is. Okay. Now notice this right here is open to the atmosphere. So here there is a pressure felt, the atmospheric pressure. So this is PATM. That's how we'll always denote atmospheric pressure. All right, so this manometer liquid has the pressure of the atmosphere pushing down. Now here, remember we said this was open. So at this point right here, the manometer liquid has the pressure of the gas. So that'll be the gas pressure P. So that's felt right here, and that's going to push down. So as this gas pressure P pushes down, it's going to cause this fluid to rise up into this tube here. Okay, so the height that's measured is going to be the distance from this line up to the top. So we've got L. All right, so that is going to be the height of the liquid column of mercury. Now, with that being said, we can get an equation for our pressure in the tank. So P is going to equal the atmospheric pressure plus the density of the manometer liquid, so rho, times G, which is gravity, times L. All right. And then let's just define these so everybody has it in your notes what they are. So PATM is atmospheric pressure. Rho is the density of the manometer liquid. And then G is gravity. And then capital L is the height of the liquid. All right, so using that equation, you can find the pressure in the tank. Okay, so very simple equation. If you have to take fluids again, or take fluids in the future, you will see this equation again. All right, but that's the equation. So that's a way you can measure pressure in a tank, for example. Now let's switch over to a barometer, and you've probably heard of a barometer before, because barometers are used a lot when you talk about weather. So this device looks a little bit different. This one, let's think of it having a dish, and inside of this dish there's going to be a fluid. And again, this is going to be a fluid with a high density. Now what happens is they're going to stick a tube into this dish. Now what we get when we do that is the atmospheric pressure, because this dish is open on top, the atmospheric pressure is going to push down on this fluid And then what happens to the fluid inside of this tube here? Yeah, it's going to rise up. Okay, so the fluid in the tube goes up like this. So again, we end up with a column of liquid. So this here is L. Whoops, that got really blurry there. All right, so we've got this column L, and now we can use that to find our pressure. This one's going to be used to find atmospheric pressure. Now there's one more pressure we haven't mentioned. There is a very tiny vapor pressure in here between this liquid and the top of the tube. So we'll just call that P vapor, but it's usually really small. So with this you could measure your atmospheric pressure, and that's going to equal that vapor pressure plus rho of your fluid, so the density of this fluid, and I have M here because it's usually going to be mercury, times G, which is gravity, times L. Okay. Now like I said, this is usually small, so typically you can say your atmospheric pressure is approximately equal to the density of your liquid times gravity times the length L. All right, so there is that equation. So that's just a couple of examples of how you can find pressure using a liquid. All right. So next, let's talk about our pressure units, because we haven't talked about units yet. Let's look at the SI system first. So for the SI system, we're going to have a Pascal, and the symbol for that is PA. And 1 Pascal is equivalent to 1 Newton per meter squared. Okay. And if you have trouble remembering that, remember pressure is F over A. Remember a Newton is force, A would be meters squared. Okay. Now 1 kilopascal is equivalent to 1,000 newtons per meter squared. Then we've got a unit called a bar. So 1 bar is going to be 10 to the 5th newtons per meter squared. And then finally a megapascal. So 1 megapascal is 10 to the 6th newtons per meter squared. All right, now we're going to use these, all 4 of these, quite a bit. So you might want to make note of them so they're easy to find if you're not going to remember them. In the English units, we got a lot fewer things. So we have pound force per square foot, or we have pound force per inches squared. And this one is usually said PSI. It stands for pounds per square inch. Okay. Now we also have the atmospheric pressure. Okay. And you'll use this one a lot. So 1 standard atmosphere we're going to write as 1 ATM. Okay, and that's going to equal 1.01325 times 10 to the 5th newtons per square meter. That's equivalent to 14.696 psi. And there's also another unit called millimeter mercury or inches mercury. So 1 atmosphere is equal to 760 millimeters of mercury, and that's equal to 29.92 inches mercury. Okay. So this is your standard atmospheric pressure. So this is at 1 atmosphere. That's going to be your PSI value that's associated with 1 atmosphere. Okay. Now, our pressure that's used in our relationships that we're going to be developing is absolute pressure. Okay. And that's important because your pressure devices, they often indicate the difference between the absolute pressure of the system and the atmospheric pressure. Okay, so the pressure readings you would get from a pressure device is not necessarily going to be the value you'd want to use inside of your equations. Okay, so what you're going to end up getting from those devices is what's called gauge pressure. All right, so gauge pressure gives you the absolute pressure minus the atmospheric pressure. Okay, so this is the pressure you get from the pressure devices. It's the difference between the absolute pressure and the atmospheric pressure. We need the absolute pressure for our equations. All right. Now let's kind of draw out a picture that kind of represents what's going on there. So let's just do like a bar graph. All right, so this one here is going to represent the absolute pressure. Okay, so there's absolute pressure. Below that, let's put one here. This is going to represent the pressure of the atmosphere. Okay. Now this difference right here, that is your gauge pressure. Okay. So basically it's just telling you how much pressure above the atmospheric pressure you have. That's all gauge pressure is. Now you can also have a vacuum pressure. So in that case, your atmospheric pressure is going to be higher than the absolute pressure. So this right here would be a vacuum pressure. And the equation for that is going to be atmospheric pressure minus the absolute pressure. Okay, so a couple of different things to look at. The one we're mainly going to focus on is going to be this gauge pressure, and sometimes this gauge pressure is written as P sub G. So either one, but this is an equation you need to understand, and you need to understand the difference. Okay, so your absolute pressure is going to be the pressure of your system, so think about the pressure in the tank. And then we've got this atmospheric pressure. Okay, so there you go. And we'll revisit that when we get to our examples. Okay, so let's stop that video here before it gets too long, and I will see y'all next time.